So, today in this session we are going to learn about viscosity. So, viscosity, here we will talk about two types of flow, one is laminar flow and another is turbulent flow. So, we have seen a streamline flow, that is a steady flow is also a streamline flow, and in a streamline flow, so when that steady flow changes into unsteady flow, then we say that there is a turbulence. So, the flow when it is steady or streamlined will be laminar, and when it becomes unsteady then it will become turbulent. That means they are the same steady flow and unsteady flow. Now, I will talk in terms of laminar flow and turbulent flow. So, we will see why we call it laminar flow. So, the basic definition of fluid is that it yields to the slightest effort made. So, this statement, this definition we put when we learnt this fluid statics. So, but this is an ideal fluid. A real fluid will apply a shear strain. So, Newton did a lot of experiments. So, what he did, he took a vessel. So, he took a vessel and then he put a rotating drum in it. So, this drum is made to rotate and then it is put inside water. He observed that this rotating drum stops after rotating some angle, it stops after some time. That means this water here, this liquid here has applied a torque, and so this torque, this friction between these two, which we call viscous, that the shear strain this liquid applies on this in order to stop it will be due to viscosity. So, this is the friction that between liquid layers will be called viscosity. So, if we take a bucket full of water and if I turn that water and then we release it, after some time the water will stop and again. So, all these experiments, observations indicate that the liquid has a friction and it applies a little stress to when we want to shear it. So, this little strain, that is called the viscous drag, the viscous force. Now, in order to understand viscous force, what we do, we use a ink method. Ink method means, suppose it is a flow. So, if a liquid is here flowing and this is on a plane surface, a liquid is flowing. So, what we do, we put a injection syringe with different colors of ink. So, this is red, this is red. So, when I put a red ink here and I put then another syringe here with different colors. So, now you see here. So, this is red and this one. So, when I release some here blue color suppose. So, by releasing small amount of inks, when the liquid is flowing, I observe that this forms a filament and this forms a filament. So, this is red line and this is blue line. So, this clearly indicates that the particles, this ink has been dropped here and this flows along a particular line and this one along a particular line. So, since different layers flow in the fluid flows in different layers which do not mix, the fluid particles do not mix like this, and so we say this type of flow as laminar flow. So, laminar flow, this will be laminar flow. Now, after when the velocity of the flow is very large, we will find that they will mix up this color and we say that now there is no laminar flow, this is a turbulence. So, why I call such a steady streamline flow, as because the different layers are in the form of different particles, they move in different layers. So, we call it a laminar flow. Now, so let us see how what is the mechanism of viscous flow. So, we have seen that in a streamlined flow, the different layers of fluid flow like this. So, you see from here to here we have one layer, here to here one layer that is flowing, and we have another layer here to here. So, this is different layers flowing. Now, why we have viscosity? What is the cause of viscosity? So, there are two main causes of viscosity. One is the exchange of particles. Suppose this layer is moving with a velocity V1 higher than V2. So, this is V2, but V1 is higher. So, this is having more velocity, this is more velocity, this is less. So, now it is more velocity. So, what will happen? There will be an exchange of particles between them. So, when the particle will be exchanged, so the exchange of particles between different layers causes a drag force. So, this exchange of particles is also there. And second important is the exchange of momentum. So, the exchange of momentum between the particles of different layers. So, two things are there. The mechanism of viscosity involves two things. One, when the two layers, fluid layers, laminar flow means different layers will have different velocities. So, what will happen? This particle goes in this medium. So, automatically this medium, these particles have a lesser velocity. So, when it goes to this medium, suddenly they get the velocity, their velocity is increased. So, they give a back reaction force. Whereas, these particles when move into this medium, they are having larger velocity and here lesser velocity. So, they impart momentum along horizontal. So, they are dragged in this way. So, this layer try to increase the velocity in this direction and this layer try to decrease the velocity by giving a momentum in this direction. So, this is the exchange of particles between different layers. So, there is a physical exchange of particles. So, the particles go along with their momentum. Now, second thing is that exchange of momentum between the particles of different layer by collision. So, what happens? It may be that this is here going like this and then they collide and then come back exchanging momentum with each other. So, there is physical exchange of particle and there is a physical exchange of momentum, two mechanisms. Now, in liquids both these takes place, but in gases the exchange of momentum dominates. As a result, what happens? In gases at higher velocity, at higher temperatures, higher will be the velocities and higher will be the exchanges. And so, here the viscosity of the liquids decreases with rise in temperature and the gases, the viscosity increases with rise in temperature. So, because more and more velocities will be there with rise in temperature, so more and more exchange of momentum takes place and so more and more viscosity of gases. Thus, we can say viscosity of gases rises with rise in temperature. So, with rise in temperature, the velocity, RMS velocity of the gas molecules rises, they collide more frequently with larger velocity, therefore transferring momentum large and large, so their viscosity is more. Whereas in liquid, the exchange of particles between different layers is because the viscosity is because of exchange of particles. So, with rise in temperature, their molecular velocities increase, but this is not so much affected. So, their viscosity is actually decreasing with rise in temperature. So, now let us see the laminar flow of a liquid over a plane horizontal surface. So, we have a plane horizontal surface like this and a liquid flows over this. So, this is the horizontal surface. I have shown the, so the liquid up to this height is there and the liquid at the top will have a larger velocity, and we see that at the bottom the fluid flowing adjacent to this floor will be at rest, and as you go on the fluid flow will be like this. So, when a fluid flows over a rough static surface, that means this should not be moving, then the fluid just above the surface is at rest with respect to it. The fluid flows in the form of different layers without getting mixed. So, we call such a flow as a laminar flow. It is the same steady streamline flow will be called a laminar. This special name because of the different layers of flow. We call such a flow laminar flow. Now, the velocity of the top layer is the maximum and it increases linearly with the distance from the static surface. So, you can see here thus the velocity profile is as shown in the figure. So, you can see these different layers. So, this shows the magnitude of these lines shows the velocity. So, the layer just adjacent to this surface is at rest, and as you go away the velocity increases. Now, so this is when this surface is a plane surface, but now if we have a tube, then what will happen? Then when such a liquid flows through a cylindrical pipe, then so this is the cylindrical pipe and the fluid is flowing from it. So, when such a liquid, that is a real liquid, flows through a cylindrical pipe, then the layer adjacent to the wall of the pipe is at rest. So, this layer is at rest and the layer and the cylindrical layers. So, what will happen? So, the cylindrical layers, that means the fluid within this cylindrical shell all will have the same velocity within this shell. So, they will form a velocity profile like this. So, that is the at the center the velocity will be more, as you go on the velocity will decrease and finally it decreases to 0. So, this is the curved profile. If we have, so the layer adjacent to the wall of the pipe is at rest and the cylindrical layers will have velocities increasing towards the center. This is not a linear profile, we will see later on. This profile will be actually parabolic. So, but for plane surface it will have a linear profile and for this we have a parabolic profile. So, now we will see what is Newton's law of viscosity.